Hi everyone, I'm going to continue on the lesson topic 6. Topic 6 is about system of linear equations. So maybe if I zoom in, it will be more readable. Yes, so when we have a system of linear equations, so means just we have several equations. Okay, so in this course we just work with two equations and two unknowns, but it can be for 3 by 3, so 3 equations, 3 unknown. It can be for more. And I remember when I was a student, we used to have like we used to write computer programming, like we used to do programming for like more just higher dimension. So for example, more than 3 by 3, so 3 equations, 3 unknown. But here we really simply can handle 2 by 2. So what do I mean here? So what I mean here is so look, I have linear equations, and how many? I have two equations. Usually when I say linear equation, you just remember this. So it's y equal mx plus b. Okay, so you say, okay, so if I have two, then I have y equal mx plus b, m1, m1 b1, and y equal m2x b2. X and y, no, you don't need to change. You don't need to change them to x, y1, y1 because it's just varies. So it's just variable. Okay, so they change. But when I have two linear equation means I have two different slopes, and so I assume I have two different y-intercept, and you will see if they are not different, so what happened. So you think about this. But in general case, we usually represent two equations this way. So it's like with like a standard notation, not a slope intercept form, so a standard form. Okay, so it just in a standard form. So it's like ax plus by equals c, and dx plus ey equal f. Okay, so you have two equations, two unknown, and so you want to find the solution. When I say solve this system, means I want you to find one x and y. Okay, so one x, one y that satisfy both equations. Okay, so that's the main point. Satisfy both equations, not just satisfy one of them. If it satisfies just one of them, means it just solution to one of them, not solution to both of them. So it's not solution to the system. Okay, so again here you will see just 2 by 2. You see two equations, two unknown, x and y usually. Okay, so I can use many other variables, so with just many other letters, but we just as agreement we use always x and y. Okay, so it's the first thing come to your mind is this one, but we usually show it this way. Okay, so here, so when I solve it, so as I said, when I solve it, when I substitute, for example I say the answer is x1 and y1, for example, and then you will say, okay, so when I substitute in the first equation, this is equation 1 and this is equation 2. When I substitute, for both equations, I see left side equal right side. Means if I substitute ax1 plus by1 equals, it is equal c. And when I substitute dx1 plus ey1, when I calculate, it is f. Okay, so left side equal right side for both equations. So that means I'm solving a system, several, okay, several equations, and all of them are satisfied. And for you, it's just 2 by 2. Okay, not more than that. Okay, so usually based on my experience, it's hard for a student to really see and visualize the solution in terms of graphically. Okay, so I like to show you, talk about graphic as just at the beginning, and then I continue to questions. And so here, when I say two system, just one system of linear equations, which means I have two equations. Okay, when I say I solve it, this can happen. Okay, so when I say I solve it, I can find one point which satisfies both equations. Means graphically that point is the intersection of two lines because that point is on both equations. Okay, maybe you would say, how about if both of them are parallel? If both of them are parallel, they don't touch each other. Oh, if they don't touch each other, then it means there is no solution. And you will see in future. And how about if they are both top of each other? So means they are the same line. When I have the same line, how many solution I have? How many solution? Oh, I see I have infinity number of points which are on both lines because both lines are top of each other. So I have infinity number of solutions. So I may have no solution, one solution, or infinity number of solutions. So I want to see all of them in just equations, and I want to see pick just the equation and the type of the question. Okay, so before I go to algebraic method, I like to do it graphically. Graphically, as I said, when you graph it, when you see the intersection point, that's the solution, and it's very good to find it by graphic. But I would say when you do it graphically, always make sure to check the point. Means check if both equations are satisfied. Means if you sub in both equations, left side equal right side. Otherwise, because graphically maybe we don't graph it, for example, very accurate, and then for example we find a point which is slightly different with the real point, with the solution. Excuse me. So okay, how do we do it graphically? Graphically, you have to plot one line, you have to plot the second line. Any method for plotting you can use. I recommend the third method, which is a slope intercept method, because that's faster, but you can go by table of values, you can go by x-intercept, y-intercept, you can do that. And determine, so then you can find the line of, so where is the intersection, you can find it. Oh, the intersection is the solution, and you can say, okay, that's that. But I recommend number 5, I recommend check the answer. Okay, check the answer, you have to do that always. Okay, so here, for example, here I have two equations, both of them are in just slope intercept form, doesn't matter. So it's easier for me if I have it in a standard form, then I have to change it to this because I want to graph it. Okay, so now I can graph the line, and then I can see where is the just the intersection. Okay, so let me say, like here, for example, I do this, here I do this one. So look at this, one of them is I have to find -2, and then I have to do 3, which is rise over run. One of them I have to find 3, and then I have to do 1/2. Okay, so I need room here. So that's for example, I can say 2, 4, 6, for example, and here I can say -2, -4, and -6, and here is 2, 4, 6, and here is -2, -4, -6. Okay, so now I find the 3, okay, which is here. Then I look at my, oh sorry, -2 I have to find. Okay, so I can do this one first. 3 here, and which is y-intercept, and then rise over run. Rise over run is 1/2. Means when I go to 2 to right, I have to go 1 up because positive. Okay, so I go 2 to right, and I go 1 up. So it's here. So 2 to right and 1 up. So then I can just graph. Okay, so how about the next one? Okay, so this one is here. Okay, so the red. Okay, so I change the color and I do it for the other one. Okay, so I find -2, and I have 3/1 for rise over run. Means when I go 1 to right, because a stop is 3, so when I go 1 to right, then I have to go 3 up. Okay, so I find here, then I go 1 to right, I have to go 3 up, so it's here. Then I can just find, okay, I can do this, and yeah. Okay, so I look at here and I see, oh, okay, my solution, it might be 2 and 4, right? 2 and 4 here. So okay, so I see 2 and 4, and I check my work to see if it's if it's the case. Okay, so I see, okay, 3 times 2 minus 2 is 6 minus 2, which is 4, equal 4, perfect. And the other one is 1 over 2 times 2 plus 3 is 1 plus 3, which is 4, equal 4, perfect. Okay, yes, so that's a solution here. See what happened here. Oops, what happened here is I just graph my first line, I just graph my second line, and then I find the point of intersection. I check my point of intersection in both lines, and I see, oh, that's the solution. So means this system of linear equation, so if I show my system of linear equation this way, for example, y equal 3x minus 2, y equal 1 over 2x plus 3, or in more just like a general case, we usually show it this way. So it's minus 3x plus y equal minus 2 and minus 1 over 2x plus y equal 3. Okay, and then we say, okay, so the answer is 2 and 4. So means if you substitute x equal 2 and y equal 4, both equations are satisfied, and in both equations you have left side equal right side. Okay, how about for this one? Oh, for this one I see more like just another way. I see another way. How do I see it? I see it in a standard form, not a slope intercept form. Doesn't matter, doesn't matter. If I want to graph it so I can find a slope and I can find a y-intercept, how do I do that? Okay, so for this one I can do minus 6y, or I can change minus 6y to the other side. Okay, so 6y is 4x minus 12. Y is 4x divided by 6 minus 12 divided by 6, which is 2x over 3 minus 2. Okay, perfect. And how about that? So here I do, for this one, I do 2y equal so 2y, I keep it this way. Okay, so 2y equal 2 minus 2x plus 6, and then y is minus, y is minus x plus 3. Okay, so now I have these equations. Okay, so this one and this one. Okay, so that's that. Okay, so here a slope is 2 over 3 and y-intercept is minus 2, and here a slope is minus 1 and y-intercept is 3. Okay, so now I can graph it. So like for example, let me see. So I can do this. Oops, not very well. And I can do this. Okay, so 2, 4, and 6, minus 2, minus 4, and minus 6. If I go one by one, I have to continue the whole way, the whole one by one for the whole x-axis. And then I have to do 2 and also 4 and 6. And then I do minus 2 and minus 4 and minus 6. Okay, so now I find minus 2. For this one, I find minus 2, and then I go 3 to right, 2 up. Okay, so I go 3 to right, and then I go 2 up. Okay, so I go here and I can just connect. Okay, so this is this one. Okay, so how about the other one? I find 3. Okay, I find 3, and then I look at my slope. My slope is minus 1 over 1, means I go 1 to right. Remember, I always go to right. Okay, I go 1 to right, and then I go 1 down because it's negative. Okay, so I go 1 to right, and then I go 1 down, and then I just connect it. Okay, I can see if let me see, I can see 3 and 0, so 3 and 0 is the solution. okay, but I'm not really sure, so I recommend that you check it. Okay, so let me see. So I'm guessing here and then I doing it. Okay, so 4 multiple 3 minus 6 multiple 0 is 12, which is equal 12. Perfect. 2 multiple 3 plus 2 multiple 0, which is 6, equals 6. Perfect. Yes, it is the solution. Okay, so now I can say the solution is the intersection, as you see here. So the intersection, so the answer is the answer which satisfy the system, means satisfy both equation, is 3 and 0. Okay, so here and then I can talk about this question, which is very beautiful when you do it graphically. Okay, so this question here is, okay, so let me see. This question here is, a homeowner needs to hire a contractor to do some repairs on a house. Okay, so usually you want to consider many things when you want to hire someone. Maybe you know the person, maybe you trust the person, maybe you don't like the person. So these things. Here we don't think about those things. Here we just think about the amount that we have to pay, just financially. So here when I say which one you hire, so this means just financially. Okay, so it says, so we have two companies and we are comparing these two companies. One of them at the beginning I have to pay 350, and per hour I have to pay $100. One of them at the beginning I have to pay less, but per hour I have to pay more. Okay, so I have to see for how many hours, for example, easy contracting or beneficial, or for how many hours helpful contracting or beneficial, or for how many hours they both are the same. Okay, so it's very beautiful when you do this question in just graphically. You can it can show you, and also I have to say it's a really good knowledge and very good skill when you are able to read the graph. When you look at the graph, you know where to look for title. You know when you look at each axis, you know what does each axis mean. For example, if I say each axis I multiply by 10,000 means I'm showing each number, for example, divided by 10,000, but you can multiply each number by 10,000, because the same as what we did in topic 4. Okay, so we were graphing, it was resistor or something that we had 10,000 in each number, so we just didn't include it in y-axis. So it's a very good knowledge when you are able to read the graph. So which one is more, which one is less, so how many more, how many less, how do you compare to graph. Okay, so here you can see a little bit of it. So okay, so easy contracting, I go with yellow. So easy contracting is okay, I have to pay $350 at the beginning. At the beginning means by intercept, because you don't pay this several times. This is by intercept, you just pay it once. Okay, and you pay $100 per hour. Okay, so I can write here. So the cost, okay, the cost is 350 plus 100 per hour. Okay, so it's a t. Okay, set t. So use t. Determine equation that relates time t to the cost. Okay, so it's here t. The next one is c. Okay, so I can make that yellow. The next one is helpful contracting. Okay, helpful contracting is you pay at the beginning, you pay 150, but per hour you pay 150 as well. Okay, so we have to see, you cannot say which one is beneficial unless you graph it and you see it. Okay, so this one is here. Okay, I know for one of them you pay more at the beginning, but you pay less per hour. For one of them you pay less at the beginning, but you pay more per hour. So it depends on how many hours you have. Okay, so now you want to graph it. So you want to graph it here. Okay, so you here you can go by so for example, I can go by table of values. For example, here when I want to graph it, because I want more accurate points. Okay, so that's one thing to consider. And also I don't need to have negative for any of them, because of course it's not negative time and it's not negative cost. Okay, so for the first one that I can make it yellow. So at the beginning, when t is 0, I pay 350, because at the beginning I pay that. And then after 1 hour, I pay 450. After 2 hour, I pay 550. So after 3, I pay 650. So at 4, I pay 750. And 5, I pay 850. And 6, I pay 950. Okay, the reason I go to 6, because it's gives me a clue in the question that 2 hours, 4 hours, 6 hours. So I don't need to go more. Okay, so I need to have more information, okay, in order, otherwise you would say, okay, so how many? So here I don't have enough space, so maybe I can, okay, I can go here and I can do this T and C, and 0 350, so 1 450, 2 550, and 3 650, and 4 750, and 5 850, and 6 950. Okay, how about the other one? So here I can make it yellow. And how about the other one? Okay, so the other one may be more space here. So T and C, which is helpful. So at the beginning you pay 150, 1 hour. After 1 hour you pay 150 plus 150, which is 300. And then 2 you pay 450, and then 3 um you pay 600. And then, because let me see, 150, and let me see, okay, so 3, yes, 600. And then after 4 you pay so 750. 5 you pay 900, and 6 you pay 150. Okay, 150. So here I would say, okay, so I just don't need any negative, so I can graph it. Okay, so here I use table of values. Again, I want to explain, I use table of values because I wanted to be more accurate and more accurate point I want to show it. Otherwise I can go by a stop intercept method. I can go with that. This is more accurate, and here I don't need any negative. Okay, so I do 0 0 1 2 and 3 and 4 and 5 and 6. Oh, perfect. So here I can go 2 by 2. Okay, so I can go 2 by 2, and I can write t here. Okay, time, and here I can write hour. Okay, so hour, you can have title. Okay, how about the cost? Okay, so the cost is dollar, right? The cost is dollar, and because I should go to 150, sorry, 1050. So maybe I go 100 by 100. So this is 100, and this is 200, and this is 400, and this is 500, and this is, oh sorry, um, let me see, 100, 200, 300, 400. So it's 600, that's 800, that's 1000, and that's 1200. Yes, yes, perfect, I have room. Okay, so let me color this one for the other one, helpful contracting. And then, okay, 0 and 350. So maybe I can, for this one I can do red, and for this one I can do blue, or maybe green. Okay, so red. 0 and 350, so it's 100, 200, so it's here. And then 1 and 450, so 1 and 450, 2 and 550, 3 and 650, 4 and 750, 5 and this one, 6 and 950. Okay. How about the other one, green? So 0 and 150, you start here, and 1 and 300, 2 and 450. Am I right? 2 and 450. Yes. Okay. So 2 and 450. So it's here. Yes. 3 and 600. 4 and 750. The same thing. 5 and 900. 6 and 1000. Okay. So that's that. Okay. So graph each equation on the grid provided for up to 6 hours. See, it says up to 6 hours. Otherwise, I don't know how many hours. So I really have to have this from the question. Okay, so here it said. Okay, so you determine the equations, you read the question, you understand what's going on. Remember, you are just comparing them financially. You are not considering anything else. In reality, you always consider many other things. Okay, so then you graph it. So it's done. We did. What does each equation represent? Okay, so each equation shows for how many number of hours, how much you pay for each company. Okay, so again I say reading the graph is a very good skill. So when I look at y-axis, I see, okay, so it's cost and it's dollar. When I look at x-axis, it's time, and so I go 2 by 2 here. Here I go 100 by 100. For this one, I go 100 by 100. Okay, so 100 by 100 for y-axis or C. Okay, for C, I go 100 by 100. So here, yes, and then I can see here. Okay, when you look at the graph, it's so very beautiful when I look at the graph. So here, okay, I see, before 4 hours, the green one is down, is below yellow one. So means before 4 hours, the green one or helpful contracting is beneficial. Compare for 1 hour I pay 300 to the blue one and 450 to the yellow one. So blue one is more beneficial. Again, for 2 hours, blue one is more beneficial. Again, for 3 hours, blue one is more beneficial. For 4 hours, they are both the same. Okay, so they are both the same for that. Here, okay, and then when I look at after, if I have more than 4 hours, if I have 5 hours, if I have 6 hours, then I see no, the red one is lower, so I have to go with the red one. So look at there. So for 5 hours, that's 850, and for 5 hours, that's 900. So yellow one is good now. For 6 hours, that 950, and 6 hours, the other one is 1050. So that one is the yellow one is good now. Okay, so when you look at the graph, in this case that you have cost on y-axis, so you know the one which is lower is more beneficial for each hour, and you can check for how many hours. Okay, so what does this represent? Here I explain this. So I just said it. So who should you hire for 2 hours? Or who should you hire for 2 hours? Okay, so helpful one, because when I look at, so I see the helpful one is lower. Okay, for 4 hours, doesn't matter, both of them are the same, because it's exactly the intersection point. Means for 4 hours, which is 4 hours for both of them, the cost is the same. Okay, how about for 6 hours? How about for 6 hours? Easy one is good, because I see easy one is lower. Okay, that's a very good question to see. And so first of all, I have to tell you how many hours to just graph, which here it says 6 hours. And second, you can go by a stop intercept method. You can go by that method to graph it. But I wanted to use table of values, because then it give me more accurate, and I want to talk about those numbers. Okay, and when you look at those numbers, even when you look at the table of value, you can see which one is which one is more beneficial for how many hours, and which one for how many hours. If you have, for example, if you know you have 6 hours job, then it's more beneficial that you go with easy one. Okay, so uh, yeah, so here, so maybe let me see, because I had that color, so maybe here I change the color the same as, okay, so the same as the color there. Okay, here I talked about, here I just said, when I was talking about it, I just mentioned right, but okay, so I prefer, okay, to just to do this again. Okay, and then, okay, I said the green one, so here I would say, okay, so I choose this, and then I said not the red one, so I choose this, because that's the color that I use for the equation, so I prefer to keep the same color for the equation here. Okay, so if I have 5 hours, if I have 6 hours, I better go with easy one. Easy one is the yellow equation. If I have less than 4 hours, 1 hour job, 2 hour job, 3 hours job, I better go with helpful one, and helpful one equation is green one. Is just highlighted with blue, and so I just make it blue here. Okay, so that's a very nice question. And then I would say now the lesson starts now, because I want to teach you how to solve the equations algebraically. So you can just working just to see. Here I don't graph it, I work it algebraically. Of course you are more than welcome to graph it. And when you graph, it just shows you many good points. But the best, I would say the best case is just go algebraically at the beginning, and then just graph it to see, and just to pick, just to visualize everything. Okay, so here I will talk about algebraically method. So I have substitution method, I have I have elimination method, which I'm going to talk about. I have two methods here. I will show you both methods, and also I will show you some questions that give you no solution, or give you infinity number of solution. And so elimination is here, infinity number of solution as well. Okay, so from now on we work on algebraically. Okay, so maybe I stop here, and so I just continue in the next video. So I write here, so that's video 1. And so it's good that I make another video for just substitution, and then I continue to elimination. The lesson seems hard, but no, when you do practice, it's not hard at all. And just you do several practice, no, it's very nice. Just both of them are very nice methods, and you can use any of the method. But if I say go with substitution, you have to go with substitution. If I say go by elimination, you have to go by elimination. But in real case, and in reality, you can use any method that you want. Substitution, elimination, which you are going to see in future, and solve the system of linear equations with those with any of these methods. So just I continue after. Thank you.